Hello viewers, welcome to Math Tech. I am Amit Sharma. Today we are going to solve another question of abstract algebra from CSIR NET November 2020. The question is from part C. So without a delay, let's start. Question is, let SL2Z containing 2 cross 2 matrices having element A, B, C, D belongs to M2Z such that AD minus BC equal to 1. For any prime P, let gamma of P containing a matrices having element A, B, C, D belongs to SL2Z such that A is congruent to 1 mod P, D is congruent to 1 mod P, C is congruent to 0 mod P, and B is congruent to 0 mod P. Which of the following are true? Option 1. Gamma of P is a subgroup of SL2Z. Option 2. Gamma of P is not a normal subgroup of SL2Z. Option 3. Gamma of P has at least 2 elements. Option 4. Gamma of P is uncountable. The following results are very essential to learn in order to solve the question. Result number 1. Let G be a group and H be a non-empty subset of G if AB inverse belongs to H, this is for multiplication. A minus B belongs to H, this is for addition. Whenever A comma B belongs to H, then H is a subgroup of G. Result number 2. A subgroup H of a group G is said to be normal subgroup of G if and only if X, H, X inverse belongs to H, for all X belongs to G and H belongs to H. Result number 3. Let n is fixed positive integer. Two integers a and b are congruent modulo n if n divides a minus b, that is a is congruent to b mod n. Since 1 is congruent to 1 mod p and 0 is congruent to 0 mod p, we take a and d is 1 and b and c is 0. Also ad minus bc, which is equal to 1 minus 0, which is equal to 1, implies 2 cross 2 matrix having element 1 0 0 1 belongs to gamma of p, which implies gamma of p is not equal to 5. Let A 2 cross 2 matrix having element A1 B1 C1 D1 and B is another 2 cross 2 matrix having element A2 B2 C2 D2 belongs to gamma of p such that A1 A2 D1 D2 is congruent to 1 mod p and B1 B2 C1 C2 is congruent to 0 mod p. Also A1 into D1 minus B1 into C1 is equal to 1. A2 into D2 minus B2 into C2 is equal to 1. Now AB inverse, which is represented by this expression, which is further simplified as this, and this is belongs to gamma of p. Why it is so? We represent first element as x, second element as y, third element as z, and fourth element as w. If we calculate x into w minus y into z, it is equal to 1. Also, x comma w is congruent to 1 mod p and y comma z is congruent to 0 mod p. Therefore, AB inverse belongs to gamma of p, implies gamma of p is a subgroup of SL2Z, implies option 1 is true. Also, gamma of p is non-trivial subgroup, implies gamma of p has at least 2 elements, implies option 3 is true and 4 is false. Let A is another 2 cross 2 matrix having element A, B, C, D belongs to SL2Z such that AD minus BC equal to 1. And B is 2 cross 2 matrix having element A1, B1, C1, D1 belongs to gamma of P such that A1, D1 minus B1, C1 equal to 1. Also, A1, D1 is congruent to 1 mod P and B1, C1 is congruent to 0 mod P. Now, A inverse is represented by this expression, which is further simplified as this, and this is also belongs to gamma of P. Why it is so? We represent first element as x, second element as y, third element as Z and fourth element as W. When we calculate x into W minus y into Z, it is equal to 1. Also, x comma W is congruent to 1 mod P and y and Z congruent to 0 mod P. Therefore, AB A inverse belongs to gamma of P for all A belongs to SL2Z and B belongs to gamma of P, implies gamma of P is a normal subgroup of SL2Z, implies option 2 is false. Hence, options 1 and 3 are true. Thank you very much for watching my video. If you like the content, please do like, share and subscribe my channel. If you have any query, comment me. Thank you very much.